All right, let's look at examples to solve equations with radicals. And again, we'll start by isolating our radical first. So you have 4 minus square root of x minus 2. You will go ahead and isolate your radical. So we'll go ahead and move this radical term over to the other side. And to do that, we will add the whole radical term to the other side of our equation here. Okay, that should be a negative sign. So once we move this guy over, this term will cancel out from this side, and you will be left with 4 on this side and square root of x minus 2 on the other side. Okay, now once you get your radical term on one side and the other term on the other side, now you can go ahead and use the power rule. Now, since this is a square root, we will go ahead and square both sides of our equation. Because again, remember, you use the same power as the index of your radical, so your square will cancel out the square root, and you will end up with x minus 2 on this side. 4 square will give you 16. Now once you get rid of the radical, solve for x. So you start by moving the 2 over, and that will give you x equals 18. Okay, now of course, once you get this, go back and check your solution in the original equation. So 4 minus 18 minus 2. Okay, replacing your x with 18, and that will give you 4 minus square root of 16. Okay, square root of 16 we know is 4. So 4 minus 4 will give you 0. And again, you end up with a true statement, so we can say the solution set to the original equation is the number 18. Okay? So that was one type of example. Let's go ahead and take a look at another type here. Now in this one, you will see that you have radical terms on both sides of your equation. Now you don't have to isolate the radicals, because that for us, you can see you have one radical term on the left hand side and another radical term on the right hand side. So we'll go directly to step 2 and use our power rule. And you have 2 square root of m on this side, and then square root of 5m minus 16 on the other side. Since they're both square roots, we will go ahead and square both sides. Okay, so the square will cancel out the square root, the square will cancel out the square root, but that 2 will also apply to your base of 2 here. So you will do 2 squared and then square root of m squared. 2 squared gives you 4. Square root of m and the square cancel each other out, and you're left with just m. On the other side, of course, the square and the root, they are already doing cancel each other out, and we end up with 5m minus 16. Okay, so again, now once you get rid of your radicals, just go ahead and solve this equation like you normally do. So we start by moving the 5m to this side on the left hand side, which will give us negative 16 on the right hand side, and 4 negative 1m or negative m. Now since you have a negative on the m, you want to get rid of that negative, so we divide both sides of our equation by negative 1, and that will get rid of the negative signs, and you will end up with m equals 16. Okay, again, just like we did with the others, always check your solution. So let's try and substitute m with 16. Okay, and let's see what do we end up with. 2 times square root of 16 is 4. On the other side, let's see, 5 times 16 will give us, let's see, 80 minus 16. Let's see, 4 times 2 is 8. And let's see, 80 minus 16 will give us 64. Okay. And of course, you can see right here, once you take square root of 64, you will end up with a true statement. 8 equals 8. Okay. Again, since you end up with a true statement, this tells you that the solution set to the original equation is going to be number 16. Okay, we'll look at a couple more examples here. Now let's say we have something of this type. Square root of a square minus 3a plus 3 equals a minus 1. Okay, so again, you can see that you have radical on one side and other values on the other. So again, we don't need to isolate our radical. We can directly go ahead and apply our power rule. And this will again give us, since you have a square root, you will go ahead and square both sides of your equation here. So we'll square these. On the left hand side, of course, the square will cancel out the square root, and you end up with a square minus 3a plus 3 on this side. Now on the right hand side, you have a minus 1 squared, which means that you will go ahead and FOIL the right hand side. Okay, so this will be a minus 1 times a minus 1, and that will give you, once you FOIL the two, you'll end up with a square minus 2a plus 1 as your product when you go ahead and FOIL this. Okay, so again, you will FOIL the right hand side. Now once you go ahead and simplify these, now let's go ahead and start combining like terms. So we'll start by moving our a square on this side, and they'll cancel out, positive a square, negative a square. We'll go ahead and move our 2a on this side next. So once we move our 2a, you end up with negative 3a plus 2a, which will give you negative a. Okay, and how about we take the 3 over to the other side? So 1 minus 3 will give you negative 2. Now just like we did earlier, since you have a negative sign on your a, we want to get rid of that negative. We'll go ahead and divide both sides by negative 1 and get rid of those negative signs, and you end up with a equals 2. Alright, so to make sure that this will work, let's check. And your original equation is square root of a square minus 3a plus 3. Replace all your a with 2, so you end up with 2 square minus 3 times 2 plus 3. On the other side, you have a minus 1, so that will be 2 minus 1. And let's see what we end up with. 2 squared is 4. 3 times 2 is 6 plus 3, and then 2 minus 1, of course, gives you 1. And then let's see, 4 minus 6 will give us negative 2 plus 3 inside the radical sign. Okay, and then let's see, negative 2 plus 3, of course, will give you 1, so that is square root of 1 equals 1. And again, we end up with a true statement. So we can safely say that 2 is the solution of our original equation. Okay. Now all the examples that we looked at so far were dealing with square roots. Now I want to look at a couple examples where we're dealing with roots higher than that. So our first example will be a cube root here. You have cube root of r plus 1. This quantity is added to 1 and that equals 0. Now the first thing you will do in this example is, just like with any other equations, isolate your radical first. Now since you have plus 1 on this side with the radical, we will start by moving our 1 to the other side. So we subtract 1 on both sides and you end up with cube root of r plus 1 equals negative 1. Now once you isolate your radical, we're ready to use our power rule. So since this is cube root, you will raise both sides of your equation to the cube power, to the third power. Okay? Same power as the index of your radical, so the cube will cancel out the cube root and you are left with r plus 1. Negative 1 to the third power will of course be negative 1. Okay, now solve for r, get r by itself. So we start by moving the 1 over and you end up with r equals negative 2. Okay, now just like we did with all the other examples, you have to check your solution in the original equation. So r will be substituted with negative 2 plus 1 plus 1 on the outside equals 0. Okay, now this will give you negative 2 plus 1 is negative 1. Okay, cube root of negative 1 is negative 1. Right, and of course you will see negative 1 plus 1 gives you 0. So you end up with a true statement again, and your solution set will be the number negative 2. So even with cube roots, you're still following the exact same idea that you did with square roots. And this next example that we're going to look at is a one with fourth root. Okay, so in this one, you can see you have fourth root of z plus 11 equals fourth root of 2z plus 6. So you again see that you have a radical on each side of your equal sign, so you don't have to isolate your radicals, and you can start by applying the power rule. And let's see, so you have fourth root, which means you raise both sides to the fourth power. Okay, and again the fourth power will cancel out the fourth root on both sides, and you will end up with z plus 11 equals 2z plus 6. And all you have to do now is combine like terms. Once you get rid of the radicals, we will start by moving our z over to the other side. So you will end up with 2z minus z, which is 1z, or just z, and we'll bring the 6 over onto this side. So you will end up with 11 minus 6, which of course will give you 5. So you can see once you got rid of the radicals, you came up to the solution pretty quick here. Now just like we did earlier, go back and check your solution. Okay, so we're checking for our solution in the original equation, which is fourth root of z plus 11. So replace z with 5, z plus 11, and the other side was fourth root of 2z, so 2 times 5 plus 6. And let's see if we end up with a true statement again. So 5 plus 11 of course gives us 16, fourth root of 16, and then of course here you can see 5 2s are 10. 10 plus 6 will also give you 16. And you don't have to simplify it further if you don't want. You can see you end up with 4th root of 16 on both sides, and 4th root of 16 is of course 2, and you have your true statement. So again, we can safely conclude that our solution set here is going to be the number 5. Okay, and that's going to be your solution to this equation. So you've looked at a couple different types of examples. You've looked at examples with different index values. So you should be able to solve equations just like we see in these examples.